Hi, in this video we'll be continuing the H2 Mathematics 2019 paper 1. We left off at question 4 and in this question 5, they give us two functions fx and gx and we're supposed to find f inverse x and state its domain. So we know that y equals to fx equals to e2x minus 4, so we just need to make x in terms of y. So we bring the 4 over, then we take the ln of it, so you can get rid of the e, and then you just divide by 2. So we know that f inverse y equals to x, which equals to half ln y plus 4. So f inverse x is just replacing now this y with x. So it's half ln x plus 4, and x is larger or equals to minus 4. And so the domain is actually going to be from minus 4 to infinity. So why is that so? Well, because the range of this function will just be the domain of the previous function. So in this case, the range of this is from minus 4 to infinity. So of course the domain here is minus 4 to infinity. And now the second part says we will find the exact solution of fg equals to 5. So fg equals to 5, it means that gx equals to f inverse 5. So it equals to half ln 9 because you just sub 5 into here. So half ln 9 is actually just ln 3. And so gx is what? Gx is x plus 2. So x plus 2 equals to ln 3. So x must equals to ln 3 minus 2. So this should be fairly straightforward and we can move on. The next part asks us to write 1 over 4r squared minus 1 in partial fractions. And we're supposed to find the expression for the sum. So 1 over 4r squared minus 1 is 1 over 2r minus 1 times 2r plus 1. So in this case, it's just a over 2r minus 1 plus b over 2r plus 1. So to do the partial fractions, you just do the cover up rule or any method that you want. And you should be able to get a equals to a half and b equals to minus half. In which case, the sum of it equals to now half. Then you sum from 1 to n of 1 over 2r minus 1 plus minus 1 over 2r plus 1. So in this case, you just see the pattern now is 1 over 2 bracket 1 minus 2 times 1 minus 1 minus 1 over 2 times 1 plus 1. Then the second one is 1 plus 1 over 2 times 2 minus 1, which is actually equivalent to 2 times 1 plus 1, because here is just 1 plus 1. So it's 2 times 1 plus 2 times 1 minus 1, and this part is just plus 1. So it's actually 2 times 1 plus 1. And actually, if you see it, you can just do the sum of difference or telescoping sum, which then cancels out this part. So you're only left with this top and this bottom term. And the top term is 1 and the bottom term is minus 1 over 2n plus 1. And so the sum is just half times 1 minus 1 over 2n plus 1. And then we're supposed to find the sum to infinity for 11 to infinity. So 11 to infinity is just 1 to infinity minus 1 to 10. So 1 to infinity, you know from this formula that is as n approaches infinity, so this approaches half, because this part is 0. And from 1 to 10, you just sub in 10. So it's just half times 1 minus 1 over 21. So this half and this half will cancel. And so you're left with half times 1 over 21, which is 1 over 42. Moving on. Question 7. The curve now has the equation x times e to the power minus x. So we're supposed to find the equation of the tangent at the points where x equals to 1 and x equals to minus 1. So very simply, you just differentiate this using the power rule. So it's just e to the power minus x plus x times minus e to the power minus x. So the gradient at 1 will just be e to the power minus 1 plus 1 minus, here's minus, so it's minus 1 times e to the power minus 1. So it's actually 0. So we just know the equation of tangent is some horizontal line. So you just find the y coordinate, which is e to the power minus 1. And we need to find out the gradient at x equals to -1. So we just sub in -1 here. We should get 2e, and so we can find the equation of tangent using the y minus y1 equals m bracket x minus x1 formula, which will result in y equals to 2ex plus e. So I hope this is clear. And for the next part, we now will find the acute angle between these two tangents. If you draw the graph, actually you can see. So 2ex plus e will be somewhere here, and y equals to e minus 1 is down here. So if you look at it, the angle between them is theta. Well, this line is parallel to this. So actually, you are just finding theta, which is the angle this line makes with the x-axis. And we know what is this angle. This angle tangent theta must equal to the gradient of the line. And the gradient of the line is 2e. So theta is just tangent inverse 2e, which will just be 79.6 degrees 1 dp. Or you can do it in radians, then you just leave it in 3SF. Whichever is you're comfortable with. As for question 8, now we know that the arithmetic series of the first term a and the common has a difference of 2a. And the geometric series has the first term a and common ratio 2. The kth term of the geometric series is equal to the sum of the 64 terms of the arithmetic one. So we also find the value of k. So we just know a is a, 2a, a plus 2a plus all the way to a plus n minus 1, 2a. So this is n minus 1, 2a. And g is just a, 2a, 2 to the power n minus 1a. So the kth term, which is 2 to the power k minus 1a, must equal to the sum of 1 to 64. So it's 64 over 2 bracket first term, which is a, plus last term, which is a plus 63 times 2a. So this is, you can cancel the a's. So that will just be 2 to the power k minus 1 equals to 4096. And 4096 is actually 2 to the power 12. By comparison, this means k must equal to 13. Next, for part B, it says that the geometric series has the first term f and common ratio r. The sum of the first 4 terms is 0, and we also find the possible values of f and r. We'll find also in terms of f the possible values of the sum and terms of the series. So firstly, we just know that f plus fr squared plus fr cubed must equal 0. We take out the f, it's 1 plus r squared plus r cubed. Since f does not equal to 0 as given, we can delete this off, and we just get this equation 1 plus r squared plus r cubed. And we solve it using our GCE or any method. We are able to actually see that r equals to -1. And because of that, r can equal to -1, and f can take any value from minus infinity to infinity. So it's all reals except 0. And now we are also supposed to find the possible sum of the first n terms of the series. So the first n terms of the series will just be f plus fr plus all the way to frn minus 1. So in which case, using the formula, which is first term, then you have r to power of n minus 1 over r minus 1. So this part is just f bracket minus 1 holding power n minus 1 over minus 2. And this will just result in f over 2 minus half f bracket minus 1 to the power n. So that's about it. As for part C, now we are given that the sum of the arithmetic term is series is negative, the first term, and the sum of the first 4 terms of the series is 14, and the product is 0. So we're supposed to find the 11th term. So we just take what we know. We know that A plus AD plus AD2 plus 2D plus A plus 3D is 14. So it's 4A plus 6D is 14. When we also know the product is 0. But since we know A is negative, means it's non-zero, we can cancel out A and we are left with this 3. So we just need to do it case by case. So case 1 is just A equals to minus D. So A is minus 7. And in case 2, we just get that A equals to minus 2D. But then this will result in A being 14. But we know A has to be negative, so we have to reject this. And in the third case, we just need to check that A equals to minus 3D will result in A being 7. Again, a positive number, so we reject it. So the only case possible is A equals to minus D, which means that A equals to minus 7. So we now know that A equals to minus 7 and D is 7. So the 11th term will just be minus 7 plus 10 times 7, which is 63. Now, for question 9, it's a complex number question, and we now know that W can be expressed in cosine theta plus I sine theta. And we're supposed to show that W plus 1 over W is a real number. So the quick way to do this is W equals to cosine theta plus I sine theta. It must equal to E power I theta. So the best way is to always write in two forms. Then we see W plus 1 over W. What's the easiest method? Well, we just EI theta plus 1 over EI theta. This part is just EI minus theta. So in that case, this part can be expanded out again to cosine theta plus I sine theta, and the bottom part can be expanded out as cosine minus theta plus I sine minus theta, which then this is just cosine theta, and this is minus sine theta. So this part cancels out and you're left with 2 cosine theta. So this question is very algebraic and a lot of manipulation, and so the next one is 2 minus 1 over 2 plus 1 can be expressed in some tangent form. Well, the best way is, okay, so you got 2 minus 1, so that's just 2 plus 1 minus 1. So this W plus 1 can be divided by W plus 1 to be 1, then you minus 2 over cosine theta plus 1 plus I sine theta. So this is where the algebra comes in. You just need to times the conjugate from top and bottom. So you got this times this whole chunk. This whole chunk you just leave it. First you expand out this to be this cosine plus 1 squared plus sine squared theta. And then you must now simplify the inside here, which is you result in 2 plus 2 cosine theta. Then you just cross multiply back in to get this portion. And you actually see that many things cancel out. So this part cancels out, this part cancels out. So you're left with 2I sine theta, which you can expand to 4I sine theta over 2 cosine theta over 2. For this part, you can also cancel out because the cosine theta can be expanded to 2 cosine squared theta over 2 minus 1. And then the 2 will cancel out. So you're left with this. So you see that the 4 cancels out and you're left with I. Then this part cancels out. So this part tangent theta over 2, which is what you want to show. So K is actually equals to I. And the last part, we're supposed to find the complex number Z with modulus 1 and find the modulus of this expression. So we are given that, so in this case now you might be thinking of using the same method as leaving it as cosine theta plus I sine theta. But in this case now, it is easier. That will be very complicated in a sense. It will look like very messy, but you still get the same answer. In this case now, we just let Z equal to A plus IB. So we know that the modulus is 1. So square root of A squared plus IB squared is 1. This must mean that A squared plus IB squared is 1. So with that knowledge, we just find the modulus of this. We just submit now Z as A plus BI. Same thing, now we just times the conjugate, but we don't deal with the cosine signs. So in this case, we don't need to times the conjugate because this modulus can be written as the top and bottom modulus each other. So the top modulus, you just square root A squared plus B minus 3 squared, and bottom is 1 minus 3B squared plus 3A squared. Then because this part you can expand out and bottom you can expand out, we know that the a squared plus b squared is 1, so this part is just 10 minus 6b. As for the bottom, we know that it will also be this 9b squared plus 9a squared is just 9. So it's also just 10 minus 6b. So actually this part reduces to 1. So I hope you see how to do this question. Yes, you can put cosine and sine here, but then it will be the same thing, and you result in actually just cosine squared theta plus I sine squared theta equals to 1. So you don't really need to care about this a squared plus b squared, but writing a squared plus b squared of course makes the notations simpler and more clear to read. So that's all for this video. I hope you have enjoyed it. In the next video, I'll finish up the paper. So I'll catch you there. If you have any questions, please like, share and subscribe, as it will do us a big favor to boost this video and this algorithm to reach out to more people that want additional explanation. So I'll see you again. Bye.